Voyager 2 is slowly approaching the end of its incredible journey. The spacecraft is still alive, still communicating with Earth, and still collecting valuable information from a region of space that no human has ever physically visited. But after nearly 5 decades in space, Voyager 2 is no longer the powerful probe it was when it launched. Several of its instruments have already been shut down. Its available power continues to decline every year. And engineers at NASA are now making difficult decisions about which systems can remain active and which ones must be sacrificed to keep the mission alive a little longer. Yet somehow, Voyager 2 is still listening. Far beyond the planets, the spacecraft is operating in interstellar space, studying an environment that cannot be directly examined from Earth. Its remaining instruments can measure magnetic fields and plasma waves, giving scientists rare information about what is happening beyond the Sun's protective bubble. And that is what makes Voyager 2's final years so important. Because if something unusual appears in its data, scientists may have only a limited amount of time to understand it. The strange signal may come from the environment around the spacecraft. It could be a change in the magnetic field. It could be an unusual plasma wave. It could be a change in energetic particles. But there is another possibility that scientists always have to consider. The spacecraft itself is almost 50 years old. An aging instrument can behave differently. A power problem can affect measurements. A transmitter can develop problems. A system operating in extreme conditions can produce data that looks unusual even when nothing strange is happening outside the spacecraft. That makes Voyager 2 both the witness and the suspect. If it detects something unexpected, scientists have to determine whether the universe is changing around Voyager 2 or whether Voyager 2 itself is changing. And they have to do this from more than 13 billion miles away. Communication at that distance is nothing like making a phone call. A command can take roughly 19 hours to travel from Earth to Voyager 2, and the response can take another 19 hours to return. A simple exchange can therefore take almost 2 days. There is no instant control. There is no quick test. Engineers send a command into deep space and wait. During that waiting period, the spacecraft continues operating on its own. And while that is happening, its power supply is slowly shrinking. NASA has explained that the Voyager probes lose roughly 4 watts of available power each year. 4 watts may sound insignificant. For a spacecraft like Voyager 2, it is not. That small amount of power can determine whether an instrument remains active. It can determine whether a heater stays on. It can determine how much longer the spacecraft can continue collecting science. So Voyager 2 is being preserved one system at a time. An instrument is switched off so another can continue. A heater can be sacrificed to protect more valuable equipment. The spacecraft is not being repaired. It is being kept alive through subtraction. That process has already changed what Voyager 2 can observe. In 2024, NASA shut down the spacecraft's plasma science instrument to conserve power. That instrument had played an important role in confirming Voyager 2's transition into interstellar space. Then, in 2025, NASA shut down the low-energy charged particle instrument as part of the continuing effort to extend the mission. These decisions do not mean Voyager 2 suddenly stopped working. They mean its scientific abilities are gradually becoming more limited. Some of its most important remaining instruments can still operate. The magnetometer can measure the magnetic field surrounding the spacecraft. The plasma wave subsystem can detect waves traveling through the thin, electrically charged material of interstellar space. Those measurements may help scientists understand what is happening beyond the heliosphere. But Voyager 2 can no longer provide the complete picture it once could. Imagine trying to understand a storm after several of your sensors have stopped working. You may still hear thunder. You may still detect changes in pressure. You may still see flashes of lightning. But you have fewer pieces of information with which to understand the entire storm. That is the situation Voyager 2 is entering. Every remaining measurement is becoming more valuable because there are fewer instruments available to confirm it. And this becomes especially important when studying the boundary between our solar system and interstellar space. Most people imagine the solar system as something that simply ends after the outer planets. Neptune. Then darkness. Then the stars. But the real boundary is much more complicated. The Sun constantly sends a stream of charged particles outward. Those particles create an enormous region called the heliosphere. Inside the heliosphere, the Sun dominates the space environment. Outside it, interstellar space begins to become the dominant environment. But the boundary between these regions is not a solid wall. It is not a perfectly clean line. It is a complicated transition zone where solar particles, interstellar material, magnetic fields, and energetic particles interact. Voyager 2 crossed into interstellar space, but there is another side to Voyager 2's story that makes its final years even more important. The spacecraft is not simply running out of power. It is slowly losing the ability to explain what it encounters. When Voyager 2 was launched in 1977, nobody expected it to spend nearly 50 years traveling through deep space. Its original mission was focused on the outer planets, not on becoming a long-term interstellar probe. It visited Jupiter. It traveled past Saturn. It became the only spacecraft to visit Uranus. Then it continued toward Neptune and became the only spacecraft to make a close encounter with that planet as well. By the time the planetary mission was complete, Voyager 2 had already accomplished far more than originally expected. But its journey did not end there. Instead, the spacecraft entered an entirely different phase of exploration. It began studying the environment far beyond the planets. That environment is difficult to understand because humans cannot simply send another spacecraft there whenever they want to repeat an experiment. There is no laboratory surrounding Voyager 2. There are no nearby spacecraft that can instantly confirm what it detects. There is only the spacecraft itself and the faint stream of data traveling billions of miles back toward Earth. That makes every remaining instrument extremely valuable. One of the biggest changes came when NASA began shutting down systems to conserve power. The decision may sound simple from the outside. Turn something off. Save energy. Keep the spacecraft alive. But every shutdown comes with a scientific cost. When an instrument disappears, scientists lose one more way of examining the environment around Voyager 2. A measurement that could once be compared with several other instruments may now have to be interpreted with much less information. That does not make the remaining data useless. It makes the remaining data more precious. Voyager 2 still has instruments capable of studying magnetic fields and plasma waves. Those instruments can provide clues about the environment outside the heliosphere. And those clues matter because the boundary of the solar system is not static. The heliosphere changes as the Sun's activity changes. The pressure of the solar wind changes. The surrounding interstellar environment changes. The interaction between them can create waves, shifts, and disturbances. Voyager 2 is sitting in the middle of this enormous cosmic interaction. Imagine standing at the shoreline of an ocean that you have never seen before. You cannot see the entire ocean. You cannot control the weather. You cannot send another person to stand beside you. You can only measure what reaches your position. That is similar to what Voyager 2 is doing. It is sampling an environment that exists far beyond the familiar planets. And the longer it survives, the more measurements it can provide. But survival is becoming increasingly difficult. The spacecraft's power source is slowly weakening. Its heaters and instruments require energy. Its communication system requires energy. Even the ability to maintain certain operating conditions requires power. So engineers have to make decisions that would have been unimaginable during the original planetary mission. They are deciding which parts of the spacecraft are worth keeping alive. And that creates an unusual trade-off. More science today can mean less mission lifetime tomorrow. Less science today can give the spacecraft more time to continue operating. There is no perfect solution. Every decision changes what Voyager 2 will be capable of doing later. And this is why the spacecraft's remaining years cannot simply be measured in time. They have to be measured in scientific capability. A spacecraft could technically remain alive while having almost no instruments left to collect useful data. So the real question is not only, how long can Voyager 2 survive? The bigger question is, how long can Voyager 2 continue telling us something new? That window is shrinking. And communication makes the situation even harder. The Deep Space Network has to detect an incredibly weak radio signal coming from more than 13 billion miles away. Those signals have traveled across an enormous distance before reaching Earth. The spacecraft cannot simply increase its transmitter power whenever the signal becomes difficult to receive. Its energy supply is limited. Its antenna has to remain correctly aligned. Its systems have to continue functioning. And Earth has to keep listening. The communication delay also means that problems cannot be solved instantly. If engineers notice something unusual, they cannot immediately change a setting and see what happens. They have to prepare a command. They have to transmit it. Then they have to wait for the spacecraft to receive it. After that, they have to wait again for the response. A decision that might take seconds with a nearby spacecraft can take days with Voyager 2. That makes every command much more important. A mistake cannot simply be corrected immediately. This is one reason the 2023 communication incident was so significant. A small pointing error was enough to interrupt normal communication. The spacecraft remained operational, but its signal was temporarily difficult to use. That event provided a glimpse of what the final stage of the mission could eventually look like. There may be no dramatic failure. The spacecraft may simply become too